Hi, this is Mrs. Allen, and in this video we will be looking at postulates and paragraph proofs. Example 1, Points and Lines. This question is about computers. Donna is setting up a network for a company. There are 7 computers in her office. She wants to connect each computer to every other computer so that if one computer fails, the others are still connected. How many connections does Donna have to make? Okay, so when we want to look at this problem, there are 7 computers and each computer is connected to 6 other computers. The first thing I want to do is draw a diagram to illustrate the solution. So let non-collinear points A, B, C, D, E, F, and G represent the 7 computers. Connect each point with every other point, then count the number of segments. Between every 2 points there is exactly 1 segment. So the connection between computer A and computer B is the same as the connection between computer B and computer A. For the 7 points, 21 segments can be drawn. An easier way to look at this, if you start at point A and you go all the way around the outside of the figure connecting AB, BC, CD, DE, EF, FG, and GA, you have made 7 connections. If we move on to the next point B and connect in the inside and connect BG, BF, BE, and BD, we have made 4 connections. If we move on to point C and make line segments CA, CG, CF, and CE, we have made 4 more connections. If we move on to point D, we can make line segments DA, DG, and DF and make 3 connections. If we move on to point E, we can make line segments EA and EG, making 2 connections. If we move on to point F, we can make line segment FA and make 1 connection. If we move on to point G, we have already connected all of the other points with G, so there are no connections there. Adding up 7 plus 4 plus 4 plus 3 plus 2 plus 1, we get 21 connections. Another way of doing this is using this formula, n squared minus n divided by 2, where n is the number of points that you start with. So we could fill it in. We had 7 points to start with. 7 squared minus 7 divided by 2. 7 squared is 49. 49 minus 7 divided by 2 would give us 42 divided by 2. 42 divided by 2 is 21. In the figure, line segment AB, AC, AD, AE, AF, AG, BC, BD, BE, BF, BG, CD, CE, CF, CG, DE, DF, DG, EF, EG, and FG each represent a connection between 2 computers. There are 7, so there will be 21 connections among the 7 computers. Example 2. Use postulates. Determine whether each statement is always, sometimes, or never true. Explain. The intersection of plane M and plane N is point A. Well, if we look at a picture of 2 planes coming together, we know when 2 planes intersect, they always intersect at a line. So they are never going to intersect at a point. So the answer to this will be never. If A and B lie in plane W, then line AB lies in plane W. So if we think about what this is going to look like, we would have a plane with 2 points in it, points A and B. We could connect those 2 points and make our line segment AB, and then we need to decide if that line segment would also be in that plane W. So if we think about our postulates from class, we have a postulate that says if 2 points lie in a plane, then the entire line containing those points lies in that plane. So this would always be true. Line TR lies in plane M. Okay, so this one, there's a couple different ways we could look at this problem. First, The answer would be sometimes, because yes, sometimes the line TR could be in plane M, but it could not be. So our first picture, we have line TR in plane M. Then if you look to the right, we have line TR going through plane M. Or our bottom picture, we could have line TR being parallel to plane M. So the answer here would be sometimes. Example 3. Write a paragraph proof. Given that ray AB is an angle bisector of angle CAD, write a paragraph proof to show that angle CAB is congruent to angle DAB. So the first thing I would want to do is draw a picture to illustrate what I'm looking at. So I'm given that ray AB is an angle bisector of angle CAD. So I would first want to draw angle CAD and bisect it with ray AB. Now I need to prove that those two angles are congruent, angle CAB and angle DAB. So let's start off our paragraph proof. From the definition of an angle bisector, the measure of angle CAB equals the measure of angle DAB. This means that angle CAB and angle DAB have the same measure. By the definition of congruence, if two angles have the same measure, then they are congruent. Thus, angle CAB is congruent to angle DAB. Thanks for watching. I hope this helps you better understand postulates and paragraph proofs.